Now let's take a look at some more complex conversions. And what complex conversions means is that we now have mixed units, both a distance unit and units of time, and we want to convert that into what will be a larger unit of distance and time. So we're going to start exactly the same way as we started the last one, and that is with a single horizontal line separated by a short vertical line. The difference is that what we're going to do is we're going to separate the two units. Now, it's probably fairly obvious, but let me be really clear about this. When you say 13.5 meters per second, what it means is 13.5 meters in every 1 second traveled. So while it's implied that there's 1 second down here, instead of implying it, we're going to actually explicitly say that there is 1 second. So what I'm going to do is I'm going to separate the two units. The 13.5 meters I'm going to separate from the 1 second that's on the bottom. Okay, and we're going to do everything all in one conversion, but we're going to do it one part at a time. So let's first of all, generally I take care of the one on the top first. So let's take care of the distance conversion first. I want to go from meters into kilometers. Now I'm sure you know that meters will have to go to the bottom and kilometers will have to go to the top. And I know that there are 1,000 meters in every kilometer. I look to see that I get my units canceling out, and if I make the calculation right now, I'll end up with kilometers per second. But obviously that's not our final unit, so let's continue on. And now we need to take care of the seconds, but notice that the seconds are on the bottom. When we started, we used meters, and meters were on the top, so I put meters to the bottom over here. But now my units are on the bottom to start with. That means that when I want to see the cancellation, I'm going to have to put the seconds up here on the top, and I'm going to put hours here on the bottom. So I know that in every 1 hour there are 3,600 seconds. I see that my seconds cancel because one is on the top and one is on the bottom, and I'm now ready to make my calculation. Remember, we always ignore the ones. I don't see any units left except kilometers and hours. So kilometers on the top, hours on the bottom, exactly what I want. So now we'll go to the calculator, and so we're going to do 13.5, and what I tend to do is I always multiply across the top first. So let's multiply everything across the top times 3,600 equals, and now we'll divide by 1,000, and our answer is 48.6 kilometers per hour. And that's it. So we took care of the conversion all on one line, but we did each part separately. I took care of the distance part separately, I took care of the time part separately, but all on the same line. All my units canceled properly, and I end up with the right units. So let's look at one that's it's a little different, and what makes this one even a little bit trickier is that not only are there mixed units, here we have mass and here we have a volume, but the volume is in terms of cubic units, so cubic meters, and I want to go to cubic centimeters. So let's see how this one works out. We're going to start the same way. We're going to start with the single horizontal line and a short vertical line. And just like I did before, I'm going to separate the 2,530 kilograms from the 1 cubic meter that's on the bottom. 2,530 kilograms, 1 cubic meter on the bottom. Okay? Just as I did with the first one, let's take care of the one on the top first. So I know that I'm going to put my kilograms to the bottom, and I know that to go from kilograms to grams, I can do that in one step. That's 1 kilogram equal to 1,000 grams. And now, if I make my calculation, I'll end up with grams per cubic meter. But that's obviously not our final answer. So let's go ahead and extend the line a little bit. I see I have meters on the bottom. That means that I will need to have meters on the top. Now we have a little bit of a dilemma. I can certainly go meters to centimeters, but there's a little bit of a dilemma because 1 unit of meters on the top will not cancel 3 units of meters on the bottom. I know that the numbers are 1 meter to 100 centimeters, and I see the cancellation, but 1 unit up here doesn't cancel the 3 here, so how do we take care of that? So there's a couple different ways that we could do it. We could actually find out what is the conversion from cubic meters to cubic centimeters. It's not 1 to 100. Or instead, what I could do is we'll just extend the line and we'll do it again. 1 more unit of meters on the top, 1 more units of centimeters on the bottom. Now I know that the meters cubed on the bottom will cancel these two, but there's still going to be 1 left over down here. So let's do it one more time. Now I see I have 3 units of meters on the bottom, I have 3 units of meters on the top, they all cancel. What I end up with on the bottom is 3 units of centimeters, which is perfect. That's exactly what I wanted. I wanted centimeters cubed. So if I make my calculation now, I should end up with the correct answer. And let's look carefully at how we're going to plug that into the calculator. Let me remind you that it's a little tricky. You got to be careful about how you plug that into the calculator. So what we're going to do is 2530 times 1000 divided by, now I'm going to be very careful, I'm going to put in parentheses 100 times 100 times 100. And I end up with 2.53. And that is grams per cubic centimeter. Okay, now the alternative way of handling this complex calculation is to actually know what is the conversion from cubic meters to cubic centimeters. You can see what we ended up having to do was to multiply 100 by 100 by 100, which is 10 to the 6th. So had I known what the conversion factor was, I would have done it a little bit differently. I would have said something like this. This is a little more sophisticated way of handling this. This is kind of the brute force way. It works, it's very effective, but it's a little tedious because you got to repeat yourself over and over and over again. Well, let's take care of the first part. We know that we're going to do 1,000 grams for the 1 kilogram. And now we'll extend this, and what I know is that in 1 cubic meter there are 100 times 100 times 100, which is 10 to the 6th cubic centimeters, or 1 million cubic centimeters in 1 cubic meter. Remember, a cubic meter is a box that's 1 meter by 1 meter by 1 meter, or 100 centimeters by 100 centimeters by 100 centimeters. When I multiply those 3, I end up with 1 million. So just as I did before, we'll do 2530 times 1000 divided by 1 million, and I still end up with the same 2.53 grams per cubic centimeter. And that's how you handle complex conversions. You separate the units that are on the top and the bottom into their separate, always 1 on the bottom, and then you handle them individually, but you just continue on. So I took care of my kilograms to grams, and then I just went on to the next part. Meters were on the top, so let's show that cancellation. And I was left with nothing but grams per cubic centimeter, just as I was up here. Nothing on the top but grams, nothing on the bottom but 3 units of centimeters, all being multiplied together. So the trick is we're going to use that lower left box to separate the 2 units, and then we just handle them separately but still within the same long conversion.